My topic is mechanical property of the metal. So in this line, the properties come this word. So what is the meaning of this property? So property is defined as the quality of the metal, or may be defined as the specific characteristic of this metal. The different type of the metal have a different type of the properties. Like some properties are given here. Number 1 is physical property. Number 2 is mechanical property. Number 3 is electrical property. Number 4 is chemical property. Number 5th is thermal property. Or 6th number is magnetic property. Different type of the metal have this type of the properties, having this type of the properties. So now I am discussing here the mechanical property of the metal. The mechanical property of the metal are those properties which is associated with its able to resist failure as well as behavior of the metal by the use of the application of external load. The mechanical property of the metal, the sound knowledge of the mechanical property of the metal is very essentially for all the engineers, like quality control engineers, production engineers and design engineers, to select the material to design the different type of the machine part, different type of the machine components and others parts of the machines like agriculture's machine parts. The mechanical property of the metal may be defined as two forms. Number 1 is stress. Number 1 is stress. Number 2 is strain. Strain is denoted by epsilon, strain is denoted by sigma. So what is the stress? So stress may be defined as the internal resistance set up by the molecules of the metal do its deformation, to resist deformation due to the application of external load. This is the stress. The stress is defined as mathematically. The stress is equal to force upon unit area. Unit area. This is the stress. Second number is strain. The strain may be defined as the change in length per unit length. It's called the strain. The strain has no any unit. The strain is expressed in the percentage form like this. The strain epsilon is equal to change in length upon unit length. Change in length, you can see this figure. This is the original length, this is the final length. The final length L minus original length divided by unit length. So this is the changing length, delta L. Changing length divided this length. This is the strain. This is the strain form. Like this strain. The stress are classified in 3 ways. Stress is classified 3 forms. Number 1 is tensile stress and strain. Number 2 is compressive stress and strain. Number 3 is shearing stress and strain. So now you can see this figure number 1 is tensile stress. When a body or object, when a body of an object is subjected by equal and opposite force, actually tensile. Some force are induced at any section. The force are induced at any section is called a tensile stress. So in this activity, when two forces are subjected equal and opposite force in a pulling direction, so that the length of this component is increase, or cross section area is decrease. Cross section area is decrease, length is increase. It is the ratio of increasing the length to the decreasing the cross section area. It is called the tensile strain. Second number is compressive stress and strain. When a body and components or object are subjected to pushing, some stress are induced at any section, at any point, at any section. This stress is called the compressive strain. For a little consideration, you can see this figure. The decrease in length of this component and cross section area is increased. The decreasing the length and increasing the cross section area, its ratio is called the compressive strain. Third number is shearing shear stress and strain. Shear stress and strain when a two when an object when an object when an object is subjected by two equal and opposite force. The force is act as a tangentially. Tangentially the plate are tends to shear off. Shearing off. This is the shearing stress strain. This shearing stress strain. This is a Hooke's law. Hooke's law states that the when and component like this. This is a gauge length of this specimen. The upper portion of this specimen is fixed in a movable jaw. The lower portion of this specification is fixed in a fixed jaw. This is the gauge length. This is the gauge length. The metal of this component will be the mild steel. Mild steel. The Hooke's law states that. So what is the Hooke's law? The Hooke's law states that when an object is loaded up to the elastic limit, in which activity the stress directly proportional to strain. Stress E into strain, the E is equal to stress upon strain. The E is the constant. E is a constant. The proportionally constant is called the modulus of metal. The words are used E, G and K. E is called the modulus of plasticity or Young modulus in case of the tensile stress and compressive stress. G is called the modulus of rigidity used for the shearing stress. K is the Young modulus. K is the bulk modulus. It is used for the volumetric distortion. But the stress are denoted as the unit of the stress is Newton per meter square or megapascals. The stress unit is Newton per mm square or megapascals. So one question is rise your mind. So why will we take the mild steel? Why will you take the metal of this sample is mild steel? So mild steel you will take the metal of this. You get this is the stress. This is the strain. Stress strain curve. This is the O. This is the A. So Hooke's law states that the component is under the loaded up to the elastic limit. So OA is the elastic limit. So in which that the force is gradually applied. So this line is draw in a straight line. The specimen is made of a mild steel so that to get the more information. Like this is the stress strain curve. This is the elastic limit. This is for the troop stress. Yield stress. More information means elastic limit, yield stress, ultimate tensile strength, breaking point, different type of the information. More information can be collected by use of the mild steel. So the mild steel material are used for the sample. You can take the other metal you can take the other metal like a hard steel, copper, brass. So copper and brass is very costly. So in which to take the hard material, you can get the you cannot get the more information. The hard material like the stress and strain, the metal is break here, so you cannot get the ultimate tensile stress and troop stress and yield strength. So you cannot get in a to take the hard material, so the mild steel material are to get the more information. So mechanical property are very important to design the different type of the machine parts. I hope that you will like my lecture. Thank you very much.